Hello everyone, Namaste. This is Rohini Mergu from WIT Solapur. I am talking about the Stokes theorem, part 1, but it is solution of a problem using the Stokes theorem, but the problem given is in cylindrical coordinate system. So I am talking about the Stokes theorem solution, which is one half of that Stokes theorem, that is the right hand side or left hand side. So two parts have been prepared. So today I am talking about the part 1, and the question is in cylindrical coordinate system. Learning outcomes: at the end of the video you will be able to apply the Stokes theorem for the given field, and you can verify the theorem in the cylindrical coordinate system. Before going to the Stokes theorem, let us just recall the divergence theorem that we have studied in electrostatic field. The divergence theorem in the electrostatic field, it states that the outward flux of a vector field through a closed surface is equal to the triple integral of a divergence of the vector field inside the surface. So closed integral of d bar dot ds bar is equal to, triple integral indicates volume integral of divergence of d bar dv. So it is the relation between surface integral over the volume integral. Stokes theorem is very similar to the divergence theorem in the electrostatic field. Divergence theorem is in the electrostatic field, whereas the Stokes theorem in the magnetostatic field. So let us look at what is Stokes theorem. The Stokes theorem states that the surface integral of curl of a function over a surface bounded by a closed surface is equal to the line integral of particular vector function around that surface. On both sides there should be the same vector quantity. On one side there is a closed surface integral, and on another side there is a line integral. So the surface is bounded by a closed surface, and the line integral should also be a closed line integral. So the same thing mathematically I can express like this: closed line integral of h bar dot dl bar is equal to surface integral of del cross h bar ds bar. This del cross h bar is called as a curl of h bar over the surface. Now this closed line integral of h bar dot dl bar indicates that when the current is flowing from one point to another, we should consider all the components of that filament. So that closed line indicates that the complete path should be covered of the current filament. Now we are trying to solve a problem on a Stokes theorem. The question is like this: verify Stokes theorem for a given vector field h bar, which is equal to rho cos phi a rho bar plus z sin phi a z bar, which is in amperes per meter, for the volume enclosed by rho is equal to 0 to 2 meter, phi is 0 to 60 degrees, and z is 1.82 to 1 meter. And here they have specified that assume that the current is flowing in positive AZ bar direction. This is one question. Another question is: apply Stokes theorem to determine closed line integral of h bar dot dl bar for the given vector field. Same vector field I have written here, bounded by the volume, which is same limits, rho phi and rho phi have same limit. So this only when I represent rho phi I can say surface, so bounded by this surface. For both of these the answer will be same. When I say verify Stokes theorem, I need to find out LHS, I need to find out RHS, I need to check that LHS is equal to RHS, then I can say that Stokes theorem is verified. But for the second problem, where it is said that apply Stokes theorem to determine the closed integral of h bar dot dl bar, so in this case I need to find out this curl over the surface, and then whatever answer I am getting by Stokes theorem, I can say that this is equal to the line integral of h bar dot dl bar. So both will be same, but here I am just finding out RHS, but here I am finding out LHS as well as RHS. Only that difference is there. Now here I am trying to consider the first question, like verify Stokes theorem for the volume enclosed and for the given h bar, assuming the current direction is AZ bar. So in this video I am trying to cover the LHS part. So I first put Stokes theorem, which says closed line integral of h bar is equal to surface integral of curl of h bar. So here I first consider the left hand side, which is h bar dot dl bar. As this is h bar is given to us in the question, the unknown quantity is dl bar. So let us write dl bar. But I can write dl bar in three coordinate systems: Cartesian, cylindrical as well as spherical. But here I need to consider it in the cylindrical coordinate system. Why? Because given h bar is in the cylindrical coordinate system. When I want to write dl bar, let us recall the differential length in cylindrical coordinate system. I have prepared the video on the different coordinate systems. So here in the cylindrical coordinate system, let us see what will be dl bar, or length, vector quantity of length, which is also called as differential lengths. So for this small section of a cylinder, there are the three lengths which I can represent along the three axes of rho phi z as d rho, rho d phi and dz. So when I am considering the circular length, I cannot write it as a d phi because d phi is an angle. So to write it as a length, I should consider this length, which is rho, and this small angle, which is d phi. So this length comes to be rho d phi. For vertical, there is no problem, which is dz. For the radial direction, there is no problem, this is d rho. But only for this angular motion, the length is rho d phi. So if at all I want to write dl bar, which is the vector length, I can write it as like this: d rho a rho bar plus rho d phi a phi bar plus dz az bar. So along with respective unit vectors, we have written these lengths. Now let us try to find out the solution of the given question. The question is again put here where h bar is given to me. So let me write again LHS, which is h bar dot dl bar. H bar, as per this question, this one is h bar, which is given in cylindrical, so that I am going dl bar in cylindrical. Now dl bar, as just we have seen, this is the dl bar. And I can put this h bar here, I can put dl bar here. So my equation will be like this. This is h bar, which is shown in red, dot product with dl bar, which is shown in green. Let us proceed further. I'll take the same equation here. And as I know now that a rho dot a rho is 1, self dot product is 1, whereas a rho dot a phi is 0 and a rho dot az is 0. So in short, self dot product is 1, with others it is 0. So if I see in my question or in the above equation, a rho is here and also a rho is with d rho. And these other unit vectors, when get multiplied or dot product with this first term, these two will result 0, but a rho dot a rho will give me the result as 1. Similarly, if I see az dot az is also 1 because it's a self dot product. So az is in the second term and az is in the last term. So only I'll get the result of the second term and the last term, as well as the first term and the first term here. So my output of the above equation will be like this: rho cos phi d rho and z sin phi dz. So this is my equation. Now I need to integrate first term with rho, I need to integrate the second term with z. So previous equation is taken here, h bar dot dl bar is rho cos phi d rho plus z sin phi dz. Integration here is with respect to rho, here is with respect to z. And here you can see when we are integrating with rho, phi has not yet changed, so phi is 0. Remember, as per the sequence, first we should consider that rho changes, then phi changes, and then z changes. So when I am integrating with respect to rho, phi has not yet changed, so it is at lower limit value, which is given in the question as 0. And when I am integrating with respect to z, the phi has already changed to upper limit, so it should be the upper limit value, which is phi is equal to 60 degrees. So here I can put it as cos 0 rho d rho plus sin 60 degrees z dz. As we know that cos 0 is 1 and sin 60 degree is root 3 by 2. We can put that values here. Cos 0 1, so need not have to put, but rho d rho integration is rho square by 2, limits are 0 to 2. Sine 60 is root 3 by 2. So I have put here root 3 by 2, and integration of z dz is z square by 2, and the limits of rho are 0 to 2 as given in the question. The limits of z are 1.82 to 1 meter. So when I put the values, this is 2 square is 4 minus 0 divided by 2, here root 3 by 2 as it is, and here it is 1 minus 1.82 square divided by 2. If I calculate the values will be like the first term will result in 2, the second term will result in minus 1. So my final answer of LHS, which is closed line integral of h bar dot dl bar, will be 1 ampere. So this is the answer of left hand side of the Stokes theorem, which is 1 ampere. These are the references used for preparing this video.